Hey guys, how's it going? I do not have my stream set up right. That's why I looked so confused for a second there. We are going through some RML stuff right now. Here, I'm just readjusting things. Let me know if the music is too loud, as always, or anything like that. And let me fix my stream setup real quickly. Okay, I think that's good. Cool. So, we're going to be doing ambient occlusion today and RML UI stuff. Right now, I'm trying to fix up my UI. I'll explain that problem in just a second. And ambient occlusion is like the basic light just in the world. So, like, with this sunlight flooding into my room right now, you'll see, like, shadows in the corners and stuff, and that's sort of the whole idea of ambient occlusion. But there are some people who will be mad with my definition of ambient occlusion, which is basically like, if we just look up ambient occlusion Minecraft, this will be, yeah, a little bit better. So you can just kind of see it's like those shadows in the corners and stuff that you get. And I have an idea of how I want to do that, but we'll see if it actually works out or not. Yep. And anyways, Voxel Riffs and Garlfin and CGO Clan, good to see you all. So yeah, right now though, what I'm trying to do is fix up one issue that I was having, which is basically, nope, this isn't gonna work. Let's see. I was changing stuff right before stream, which is never a good idea. Okay, so it says unresolved external symbol, tile decorator, generate element data. Oh, okay, it's just because let's see. I don't have these implemented. Let's do that real quick and then I'll explain everything that's going on, so don't worry. Let's just go ahead and do that. Get rid of that. And just stub these out so that I don't get any annoying errors. So we can do that. That and that. Okay, and we should be good. I just have to return something here. We'll return 0 there. Okay, so now I can run it. Basically, there is one... Nope, I can't run it yet. Almost there. Okay, what's saying? Const. We don't have these... Oh, because I have to keep these declared as const. Let's see. Const. Const. And const. Okay, nope, that is bad. And SU Woods, how's it going? Good to see you. Nope, you can't declare them constant here. That's what I thought. Okay. Let me try and compile this again. Right now I'm struggling, but we're basically trying to get up to the point where I can show you what I'm trying to do. Unresolved external symbol. Generate element data. Generate element data. Const override returns a decorator handle. Basically what I'm doing right here. Oh, it's because okay. C++, right? I'm missing that scope. Okay, there we go. So if I do that, and now it's saying I need to mark that const. Okay, cool. So let's do that real quick. And that. And that. Okay. So now I can show you. Basically, RML UI is great, and I've started switching all of the UI over to it. So this is now RML UI, which means that it scales pretty good. I still got to work out some things, but this is better than what it was before. Before, it wouldn't do anything really. It was just kind of, this would all get out of aspect and everything, and it just didn't look good. I'm getting the buttons working, and so this is the problem I've run into. Basically, RML UI doesn't have any way to repeat an image, so I have to make this thing called a custom decorator, which will allow me to repeat this image myself. And let me turn on my mouse highlighter so you guys can see where I'm pointing. But yeah, so we're basically just going to have to create something that will repeat this, which should be pretty easy. I just have to get it to work. So that's what we are doing right now. And Garlfin just explaining, okay, cool, yeah, what ambient occlusion is. But yeah, once we get this working, I'm just gonna add a like new world, load world screen, probably. I don't know. Let me know if you guys want me to keep working on this, or if you just want me to jump into ambient occlusion, and I can just re-enable the old UI so that we can just sort of jump into that if you would prefer. Because you may not care about this, and I don't blame you if you don't. Yeah, let's actually do that. I'm just gonna re-enable the old UI real quickly, and then we'll go back to this at the end of the stream instead. So to do that, I can just go into here. And it looks like I might have to change this up a little bit because kind of remove some code. CGO Clan, your font is really bad. You can just download the official Mojang published font. It's not, if you're talking about the title screen thing, that's not a font. That's just my badly drawn text right here. This is the actual font, which is actually not that bad. This is not standard font. That's just, yeah. This stuff right here, that's bad? Okay. I'm not going to download the official Mojang font too, though, because I'm pretty sure that's not open source, so I don't want to get in trouble with that. But yeah. And SE Wood's RML UI, yes, it is like an HTML CSS library for C++. So basically, I can define my UI like this in HTML and CSS, and I can use it in my code, and it just works out a little bit better because, you know, it's a little bit easier to work with HTML and stuff. So yeah. Let's go ahead though real quickly. Let's grab my old code so that I can replace that menu code again. Actually, we'll go here. Yep. So that's, it's a really cool repository. It's got a lot of cool stuff. I'm still learning it and trying to figure out how exactly it works. So, you know, all of that good stuff when you're learning a new thing. Okay, so let's see. Let's go to source here and not there. We'll go here. Okay, and then I'm just going to copy this and we'll just kind of remove this one for now. And then I'll re-enable it afterwards. Okay, so this should give us our old stuff back. I might need to copy over a few more variables, which is this stuff. Let's see, I think I have to add those back up here. Yep, I might need to add all those back, so let me go and grab that last one as well. Okay, and then I need to, whoops, re-enable those too. So let me just grab, I think I have them somewhere up here. Yeah. Let's do that. Go into here. Actually, let's just do this. Just copy this whole thing again too. And then go into here. And I will get rid of this for now. And we'll use this one. Yeah, it's really annoying working on this GUI code right now because, like, once I start breaking stuff, I can't really switch back and forth very easily unless I do something like this. So yeah. So yeah, this is a good comparison too, just so you can see, like, this is the old version. And you'll notice, like, the text kind of gets squashed and stuff and it just doesn't look very good. And so that's one of the good things about RML too, is it automatically gets like that aspect ratio and stuff for me. But yeah, so let's go ahead and load this world again, or not, because it is corrupted or something. Or RML is corrupted or something. I don't know. It doesn't like me for some reason in there. So where is that coming from? That's, oh, I think it's because of my free function in there actually. Here, wait, let's, so this is coming from here. Oh, okay, yeah. So I'll just remove this stuff for now too. Okay. Now we should be good. So if we go back into here, we can see how we're missing ambient occlusion, and then I'll talk about my ideas and we'll see if they actually work or not. Okay, cool. So yeah, you can see, like, right now everything looks super flat because you don't have that ambient occlusion, so it's really hard to tell any differences, like in the sides of a block and the top of the block. You can especially tell with that sand right there. So this is basically what the ambient occlusion is going to help us, like, actually define edges and stuff, which will be really nice. Yep. CGO Clan, if you ask me, using HTML is the best thing for making UI in your game. HTML is not useful anyways with new technologies like Vue and React. HTML is still useful, I think. I feel like React and stuff is a bit overkill if you just need like a simple blog or whatever. You don't really need that much. I really don't mind React and CSS. I mean, HTML and CSS. especially after having worked with C# and XML. HTML is much better than XML. XML is absolute trash heap. So, yeah. But anyways, yeah, so what we got to do is we basically want to come up with a system where, right, if we have 3 blocks together like this, we basically need this vertex to be darker and these vertices to be lighter. But it's different, right? So let's actually set up a few test cases that we can sort of experiment with. So this is one test case, right? You have a block here, and a block here. And what that means is this corner is darker than these corners, right? But then you have other test cases too, right? You have something like this. We'll also try and fix this today too, where it's like doing weird lighting stuff with the water. But yeah, so you also have this test case, right? Well, now in something like this, you basically have this vertex be dark, this vertex be dark, this vertex dark, and then these ones are a little bit lighter. And then you also have like just regular block. Let's just do that. There we go. Regular block, which is, let's actually look at this real quick, because I remember there's a tutorial that shows this a lot better than what I'm doing. And we can sort of go based off what he does. So if we go here, he's got a pretty good article on all this stuff. Yeah, and so he kind of shows like ambient occlusion here and everything. Okay, here we go. So these are like the different test cases and stuff, right? You've got 3 blocks. You've got this kind of scenario where you've got a block here and a block here. And then you've got this kind of scenario where you've got a block here. And then this one where you've got like kind of the occlusion on those sides. And then you have just the basic case where you just sort of shade that side a little bit different and that side a little bit darker too. Now this is kind of the hard part, because like how do we come up with a good system? What he does is he just uses like 2 bits, and he basically categorizes these into different states. Yeah, he says the 4 different cases, and then he says the vertex's ambient occlusion, which he gets basically using for the sides and the corner. And he basically checks to see if both sides are there, and he returns 0. Otherwise, he does this thing, which returns like some sort of value, which basically just returns 0, 1, 2, or 3, depending on which one it is. And so I'm just kind of curious about how exactly he ends up using those values. So he says, the general idea is to calculate the ambient occlusion for each vertex using only the information from the cubes which are adjacent to it. Taking this into account, there are up to symmetry 4 possible ambient occlusion values for a vertex. Using this chart, we can deduce a pattern. Let side 1 and 2 be 0, 1. Okay, so maybe we can just like use this value, right? So 0 is dark, 1 is darker, 2 is... That's what I want to say, but it... I'm still not quite sure how he does this. I was going to say we could use these kind of like light values, right? Because then 0 is the darkest, that would be 0. But then like what's this vertex, this vertex, this vertex, and this vertex, right? Because you still have different values. Because like, especially when you get to something like this, right? You have brightness on one side and then these 2 sides are dark. I don't like this stuff. It's never as easy as you would think. I am kind of wondering if we can just use like light values to kind of darken different areas. So we might start with that, right? Let's start with this one because this one looks pretty easy. Basically, if you have a block on that side, and the bottom view, right? So if we're looking at this air block and we have one there, there, and there, then we can set the ambient occlusion to the lowest value, right? And so what I'll do in that case is I'll just set the vertex that we're looking at, so the vertex that's surrounded by the blocks, to like 1 light level lower. So let's go look at that code real quickly. If we go into chunk.cpp, I think we have something where we basically calculate the light values. Let's see. Generate render data. So if we go into here, yeah, so right here, this is, so we're saying only add the faces that are not called by other blocks. It's all good. Okay, and then the smooth lighting is where we're kind of looking and interpolating our light values. Okay, and this is for a face, right? So this is V0, V1, V2, V3 for one specific face. And I guess the best place to put this then would be inside of this function, right? Okay, cool, yeah. So we've got the side. So this is right, left, top, bottom, back, front. And then we're getting the vertices. Okay, yeah. So let's do this. We can basically check the block to the other side of this vertex. And let's just darken it if there's a block there or something like that. I don't know. We'll see. I'm going to draw this out because this is going to help me a little bit more if we're actually drawing this stuff out. So let's switch over here. Okay, so let's start with the right side just to try something, right? So let's say we are calculating the face of a block, right? And this is the face. And we have these 4 vertices, right? How bright do we want to make each of these vertices? Well, let's say we have our light value over here to the right of the block, and that light value is, let's say, like 10. Okay, so this is 10. And then we also have like a light value here and here and then here. So we have like light values all around it, right? And depending on those light values, we set, we average out these vertex light values. And basically what I want to do is I basically want to say, hey, for instance, if we're calculating this vertex, if we have another block up here, that was horrible. If we have another block up here and we're calculating this vertex, I guess we wouldn't do anything to the value. But say we have like something down here, right? Then these 2 vertices would get a slightly darker value. And then same thing up here. Right? If we had a block up here, then these 2 vertices would get slightly darker values. What about, and then if we have like a block here, slightly darker for those 2. Okay, I think I'm kind of getting it. We'll see if this works or not. So let's go back to the main board and just try something. So we're gonna start with the right face, right? And basically if there is a block up one and to the right one, then we want to decrease the light level by even more, right? So in this case, like if there was a block to the top and back, or I guess top and right one of these vertices would be even darker. And I didn't write this code specifically, so I'm kind of trying to figure out what's going on here. Okay, so let's check this again. Actually, let's just do something. Let's just change one of these to -2 and see what happens. Best way to code. So if we just change that to -2, I'm expecting one vertex to be slightly darker than the rest of stuff. Let's go back into here and see what happens. So we should see like, whoops. Here, let's put one up here. We should see one vertex that's like slightly darker. Can't really tell if there's anything though. And it would be on the right face. How's it going, Eddie Dev? Good to see you. We are trying to work on ambient occlusion right now, but I do not know what I'm doing, so it's a struggle right now. Let's change that to like -4 and see what happens. I might be doing this in a bad place because I think that's like averaging values, so it might not give the best. Yeah. Let's try something a little bit different. Instead of doing it in here, we'll have like a separate function which basically does the ambient occlusion, right? So this is get light vertices by side. What does that do? That takes in pointers to those. Okay, yeah, references. So then I think what we want to do is say like get ambient occlusion by side. And this will basically darken them appropriately. Or actually, wait a second. How are we using V0, 1, 2, and 3? Let's see. Okay, so what we're doing here, once again, I did not write this code. That's why I'm kind of struggling here. So so these are I vector 3s, and they just have like a -1 or something, depending on -1 or +1, right? Yeah, just like a -1. Okay, just -1s. There's not even +1s in there. And then what happens is we get the blocks, which is what this is doing. Okay, and then what it says is current vertex light, which is a uint 8 plus equals this calculated level. Okay, and then this plus okay, so then we're just like averaging all them, right? So for anything that's an air block, we just add that to our average. And then right here, okay, yeah, and then we divide by that count. Okay, and then we set smooth light vertex to current vertex light and current vertex skylight. Okay, cool. So this is where we could do something where it's like decreasing specifics. Yeah, so basically I think what I would want to do then is like say get ambient occlusion by light by side, and then we could pass I and do something similar to this. Possibly, or something similar to this, maybe. This is always harder than you think it's going to be. And Langors, how's it going? I'm doing all right. You're all good. So we've got smooth light vertex and smooth skylight vertex here. And basically I want to decrease these for certain vertices. What is this? This is V. Are we in a loop here? We are in a loop here. Okay, cool. So we do like loop over all the vertices. Oh, wait. Okay, I think I see what's happening now. I think. Okay, so verts is our... These are the vertices for this cube specifically. And I think what's happening here is this is just getting like the vertices to the left or something, like basically getting the vertices for this face. I think, I'm not quite sure. And then this basically, yeah, okay. And then this is basically getting the blocks at those vertex positions. Okay, I think that's what's happening here. So then I could use these as well. So yeah, let's pass those in. So we'll say V0B, V1B, V2B, V3B. Right, okay. And let's just do this for the side for now, and we'll try and see how this works out. So we can do that, void. We'll copy that, and that can be just a uint 8 This will be a block, as will these. Okay. So we'll do that, and then we'll just say switch side. Right, and then copy this. Okay, so we'll copy that. Okay, and then right here. Oh, and then we can do this. We can just like return an int or something, right? That's how much we should decrease it by. For right now, let's just say -1 for the right side. Return -1, okay? Just to see if this does anything, which hopefully it should. Okay, so let's get rid of all of this. This will return 0. And we can like G logger error unknown side. We should never hit that, but we will hit it for now. I mean, let's put that up in here actually. Okay, there we go. So that's a little bit better. Okay, so this should return like, we'll do -2 for now actually. We can do that, and then what we can do here is we can say wherever we were looping. Yep, okay, here we go. We can say smooth light vertex IV minus equals that. Because smooth light vertex is just a U8 vec4. So it's a unsigned integer. Okay, so it's 4 8-bit unsigned integers. Trying to think if that makes sense to me. Because why do we have 4 of them? Oh, wait, okay, and then we have V. Okay, so we're indexing into it to a specific vertex. Okay, so this is 4 vertices. That makes sense. So basically, what this should hopefully do is decrease the right side a little bit. So we should get a darker right side than the rest of the sides of the cube. Hopefully. If that works, I can at least work with this a little bit better, and we can start moving on. Okay, I think that's working. I can't tell. Actually, yeah, I think that is working. I think, if I don't fall over, I think this is the right side, right? And these are all darker. So it's kind of doing the reverse of what I expected. Because that does look... Does it, though? I don't know. I can't tell. Because all that sand still looks the same. Let's see. Let's see which way is positive for... I think x-axis is depth, so z-axis should be the right and left dimensions. Let's see. So this is x-axis. Okay, this is z-axis. This is forward z-axis. So the right face would be pointing in this direction. Okay, so this would be the right face. Let's increase it more and see if we get a more pronounced effect. Let's do that again. Let's do like -5, see what happens. Oh, it's because I'm subtracting. That makes sense. So it's increasing it. Okay, actually that makes a lot of sense. Cool, so let's see if this increases it even more. Uh-oh, now it's just darker. Which is still kind of good. Oh, and the reason we're not seeing it over there is because I'm only doing it to glowstone stuff right now, because it's just calculated light level. So if I were to do a light here, there we go. Okay, cool. So it is definitely doing something to the right face. Okay, this is a start. We're getting somewhere. That's good. Vox strips. You may get some weird stuff for blocks with light level 0. I think I clamped that in the shader, so it should just clamp to 0. This is kind of weird though, how it's like dark there and then weird bright over there. I think that's just because the sky level's messing with it. If we were to set time to, yeah, 0. Okay, yeah, so they go completely dark. We'll have to adjust that in the light shader. And it's kind of weird how it fades out like that. Okay, it's definitely doing something though. Let's go ahead and see if we can, first of all, adjust. Actually, why did I shouldn't have exited out. I can hot reload shaders. Okay. Let's see if we can adjust this a little bit in our shaders. So if I go ahead and just pull up our shaders, I'll put this over here. Okay, so composite shader. I think, oh wait, it's not in the composite shader. Wait a second. It's in opaque shader. So we have something down here. Okay, so we have the sky level, which maxes out at 7. Or no, it mins out. Okay, so 7 is the smallest that it can be for our sky level, but what about our light level? Okay, it looks like we're just using F light level, so let's just do max there. And then here we'll say reload shaders. That did not change anything. Or did it? Let's see, what are we doing here too? Let's change this to like 10. Maybe if we do that, that way we can see if it's actually changing things. Okay, yeah, so that definitely changed it. This got brighter. I don't know if you could tell over stream. If we were to increase this to like 20, you should be able to see. There we go. So yeah, you can definitely see that's changing stuff. So let's clamp that to 0 again. And I basically just need to increase the base light level because that's way too dark. Yeah, way too dark. So let's go ahead and increase that to something a little bit more reasonable, which we can do. So base light color, and then we say the light intensity is the light level over 31 to the power of 0.006. Oh, I think I can just increase this. Let's do like 0.1. Let's go into here. Okay, yeah, so that definitely brightened it up a little bit. I think it's still too dark though. Actually, I can't tell because this is 0 right now, and at least I think this is 0 right now, and these are all a lot brighter, so it looks really dark to me and just off, but that might actually be fine. Let's go ahead and see if we can do this a little bit better though. Okay, so right now we're returning -5 here, and what do we do again? We say right here, smooth light vertex minus equals get a ambient occlusion by side. This might not be the best idea too. We might actually want to pass this in as a vertex attribute, because if we pass it in like this, it means that we can't really like dynamically set stuff. For calculated light levels and stuff, that's fine, but I'm thinking about skylight levels where those don't change. And it wouldn't be good to like actually modify them here, because that could do some weird stuff. So yeah. So what we might want to do is we'll just say like get ambient occlusion by side. And then we can just say like, let's see. So we've got the smooth sky vertex and smooth light vertex, which are these things that we set up here. So then what we can do, and we have 6 of them for some reason. I'm wondering if that makes sense too. 6 for, I mean, it has to because it's working. So what do I do here? Oh, it's because we have 6 indices per square. So this is, okay, that kind of makes sense. Yeah, this code is not fun to be in. This is why I kept putting off ambient occlusion for so long, because I didn't want to look at this. Okay, so we've got smooth light vertex I, smooth skylight vertex I. So then we're going to need 6 things for ambient occlusion. And let's make ambient occlusion like, we only need 2 bits as evidenced by this thing. So we'll store it for now as like a GLM. Actually, we don't even do GLM. We can just store it as a uint8 ambient occlusion levels, and we'll have 6 of those. And we'll 0 those out initially too. Okay, so we'll do that, and then we can basically just say ambient occlusion levels I equals that. Do we want to do that, or do we want to do, because this is going to be per vertex. Yeah, so we kind of want a per vertex thing, don't we? So we kind of want to do something like that for, wait, no, does that make sense? Yeah, that does make sense. Okay. I'm kind of all over the place today. Sorry about that, guys. Because I did not prepare for this as much as I should have. Okay, I think I have that backwards. So we basically want to do this per vertex. So we'll have 6 here, 4 here. Okay, and that should give us a different ambient occlusion per vertex, and then what we can do is we can pass that through here. Yeah, okay, and then we can say ambient occlusion I. We'll add this to this giant function. Let's go ahead and find where this is declared. And that should be better. Okay, so we have this here. And then what we'll do is we'll take in a uint8. Can I do an array here? I think I can. Array of 4 uint8s, and this is going to be our ambient occlusion levels. And then let's find where we for declare this function, which is here, and this is a giant function now. Okay, and then we'll just say that right there. Okay, what's this saying? Expected a parenthesis. Yeah, I think I'm declaring this wrong. Can I do that? Don't think that's right. Let me just Google this just in case. C++ array as parameter. Okay, yeah, that's right. Cool. So yeah, we're basically expecting an array of 4 uint8s. Okay, what's this say? Oh, ambient occlusion, what I call it, levels? Yeah. So we'll do that. That should be good. Change this to that. Okay. So then we get them here, and now we basically want to embed them into our giant vertex definition. So I'm gonna have to pull up our vertex definition real quick. Which I'm looking for. Okay, here we go. So let's switch screens again real quick because we got to add to this giant monstrosity. This is not the right thing. Let's see, somewhere up here. Or maybe down here. Okay, here we go. Yep, so we basically have, this is like our vertex attributes and how we have them all stored. So I guess the next thing I want to add here is 2 bits for the ambient occlusion. So this is AO. Okay, and so these 2 bits are at I guess this would be, so these last 2 bits are set. Now I gotta do binary 1, 2, 4, 8. So that's 12, and 12 in hexadecimal is, I cannot think today, guys, man. Okay, so 12 in hexadecimal. So A, B, C, D. This is 10, 11, 12. C. Okay. So this is 0xC. And then we have a 0, 1, 2, 3, 4, 5 zeros. So 0xc, 0, 0, 0, 0, 5 zeros. And that's where we want to put these bits. Okay, let's go back here. So if we go down or up, let's look for where we have all these defined. Okay, so let's say static const int AO bit mask equals 0xc 1, 2, 3, 4, 5, and that's good. And then let's go back to where we were, which was here. And we can store this in here. So we'll say data2 or equals uint32 skylight level shifted left. And how far do we shift that left? That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2. Okay, 22. And then we'll end that with our AO bit mask. And that should be good. Okay, so now we should have that in there. Oh, and we also need to actually pass in the ambient occlusion. So we'll do that, and that will just be like a uint8. Maybe we'll do it after. Well, yeah, that makes sense. Okay, so we'll do it right there, ambient occlusion. Okay, and that goes there. So then these are all gonna break, or at least they should. Let's see if nope, I don't forward declare that anywhere. Okay, so then right here, what we'll do is we'll say like ambient occlusion 0. Okay, and compress should be taking that in now. We got that right there. Do I forward declare it somewhere? I don't think I do. Okay, yeah, I do not. So why is Visual Studio? Okay, yeah, uint8 ambient occlusion. Oh, do I just have that wrong? Yeah, ambient occlusion levels. Okay, there we go. Cool, so that should be fine. And now these are all marked as wrong. Let's also move to a new line now. This is getting very messy, but it's okay. I mean, it's probably not okay, but I just want to get it working first, and then I'll actually have to think about fixing all this stuff up afterwards. Okay, so let's go ahead and add all this stuff in. Okay, so we got 0, 1, 2, and then we've got 0, 2, 3. Okay, so that should send it to our shader. Now we got to modify our shader, which is going to take in up here our hash define AO bit mask, which we're going to say is UXC 1, 2, 3, 4, 5. Okay, and then we can go ahead and say extract that. So we'll say void extract AO in data2 out. I guess it can be a uint. It really doesn't matter too much. Yeah, we'll probably do a uint. Or maybe just an int. And this will be our AO value. Okay, so we'll do that. And then we'll say AO value equals something similar to this. Kinda, not quite. So we'll do that. This will be an int data2 and AO bit mask shift left 22, which is what I think it was. Yeah, so that's shifted left 17. Okay, and that should be 22. Cool, so we got that. And then we basically want to pass that through. So what we can do is put an out variable here. We'll say out int f ambient occlusion. Okay, take that. Oh crap, and we're gonna need this for sky, and we need this for normal light level. Dang it. Okay, so we're probably gonna need 2 of these as well, which is kind of annoying. And Eddie Dev, thank you for playing Mario Death. Unfortunately, I didn't hear it because my volume isn't up enough, I guess. I don't know. I'm still not sure how sound alerts and everything work, so I'm not good with Twitch. Okay, so that kind of threw a wrench in the works. We've got to go back to the drawing screen real quick because I need to add 2 more bits for Sky AO. Okay, right, so we've got 2 more bits here, Sky AO. This is 1 and 2, so that's just 3. So hex 360 is what we'll use for that. Let's go and just add this right now and get the hard part over with. Okay, so what we need to do is we need to say, let's go to where these things are defined. Okay, and then we'll say static const int Sky AO bitmask equals 0x3 1 2 3 4 5 6. That's good.
Wow.
Okay, and then if we go back there, we can do this. And then we'll take in 2 Sky Ambient Occlusion. And then this will just be shift left 24 with Sky AO bitmask. Okay, so we've got both of those in there. We're gonna have to update all this stuff now again. So we'll do Sky Ambient Occlusion levels 0. Copy that. Paste it there, 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 and there. 1, 2, and 2, 3. You played Owen Wilson. Wow, thanks, Eddie Dev. Yeah, I'm not hearing these for some reason. I'm not sure why it's not playing. I don't know if it's just because Twitch or Streamlabs or what. Okay, so, but it's very appropriate for me not being able to hear it. So, we've got the Sky Ambient Occlusion levels coming through now. Okay, so we can say that, copy that, go back to where this is, add it here. Okay, and then go back to where we actually do this. And we'll do this. Wait a second. No. I don't need to do any of this because the ambient occlusion levels don't change for Sky or... I'm stupid. Okay. They don't change if you're doing Sky or if you're doing the regular light level. They just affect both of them. So let's undo all of that stuff that we just did. Okay, undo that. Undo that. And that. And that. And that. Okay. Yeah. So that's good news. Don't need to worry about that. That's nice, at least. Right. Okay. So we're passing F ambient occlusion out. So what we want to do is we want to say like extract AO A data 2 F ambient occlusion. Okay. And then let's copy that. Go down to our fragment shader. This takes in an int that. Okay. Cool. So now we have the ambient occlusion being passed into here, and it's gonna be either a 0, 1, or 2. We've got 3-bit values because I'm gonna try and do what he's doing here. So let's do what he's doing here too. 0 is the lowest value, 3. So what we can do is, I actually think I'm gonna reverse this. 3 will be our lowest value, and 0 will be our highest. Yeah. So this will be 0, 1, 2, 3. That way we can just subtract the AO from our light levels, right? So what we're going to do is we're going to say that minus AO, or I guess I call it F ambient occlusion. Yeah. So let's do that. We'll subtract that from the Sky level and from this. Okay, cool. So now we just need to pass that ambient occlusion level. Generate render data, which I think I was doing here. Yeah, okay. So I am setting it there. Okay, cool. So let's just see if this works. Let's see what happens now. the data should be getting passed to our shader now. Okay, let's see. We got a shader error. That is true. It's got to be flat. So let's change this. This should be a flat. And we should be outputting it flat. Okay. Layout qualifiers are so hard to remember the order of too in shaders. There's like a thing in the GLSL documentation that tells you like what order you should put all your qualifiers for in your shaders, which is actually pretty helpful because there's a lot of different things. Okay, cool. I think it's, yeah, cool. Okay, it's working. Look, the right faces are all a little bit darker. If we set time to, yeah, cool. So you can see all of the sand does have darker right faces. And all of the grass up there does too. Okay, cool. This is already doing a lot of difference for the visuals of the game. Like you can actually tell where the side of a block is. So this is good. Unfortunately, we're not actually doing anything. We're just sort of setting the right face to be darker, which, you know, we could fake it for now. We could just do the right face and the back face and make those darker. And that's ambient occlusion, right? So then if we go ahead and we were to go, oh, also, how was that working? No, okay, I don't think this is, am I still subtracting here? No, I'm not subtracting. Okay, I'm curious how that was working because we should only be getting 2 bits there, so it should only ever be 0, 1, or 2. And I think I set it to something. What did I set it to? Yeah, I'm returning -5 here. What is -5 in binary? Now I gotta decimal to binary. Okay, -5. Okay, so we were taking these 2 bits. Okay, so that does kind of make sense. It's subtracting 3. So that would be the highest light level. Cool. Okay, completely unintentional. But if we were to change this to 3, it should be the same thing. And let's do the same thing for back as well. And that should give us darker sides on the back and the right side. And hey, Amethyst, how's it going? Good to see you. So let's see if that looks the same. Okay, yeah, and it still does look the same. That's good. So even though we were doing -5, it was just doing some magic there with binary. Okay, so this is the back side. This is the right side. And as you can see, kind of. Oh, here, let's actually, not that. Let's place one of these guys up here. Oops, I want to keep that one. We'll get rid of those. So you can see, yep, that side's slightly darker than that side. That side is slightly darker than that side. Cool. So it's very subtle, but it does make a big difference, as you can see with the sand, which is good. You know, I think we can call it a day and say ambient occlusion is working. Not really, but we've at least started and we can kind of identify how to do this. So now I guess, what is the next step? The next step is basically how much does ambient occlusion affect blocks, first of all, like how dark do we want to get for the darkest value? And then we also need to say something like this vertex gets its own ambient occlusion level based on the block here, which block, I guess technically it would be just based on the block right here and here. This vertex gets its own ambient occlusion level based on the block here, here, and here. Okay, so it's kind of like the, well, and here. Yeah, so it's kind of like the corner blocks, right? The blocks that make up the corner around the vertex, right? So if we were thinking about this, we would have a block here, here, and here. These 4 blocks, 1, 2, 3, 4, all affect this vertex. This is a different vertex, technically, the way we store it in memory, which is good because we actually need 2 different vertices for this, right? Because this could have a different ambient occlusion level than this one. Say we didn't have that block, for instance, this one would be different than this one. Okay, so let's go back to that article real quick and see if we can figure out what he's talking about. So basically, I think the vertex that he's trying to point out here is like this one in that corner right there, which is affected by this block, this block, this block, and that block, right? So he's saying that's the 0th kind of vertex. And I think the one he's pointing out here is this one. So for a 1 state, this is this block, this block, this block. And you can see it's the same one for that. Okay, for the 2 state, I think he's basically just saying, yeah, I think this is the vertex he's pointing out here. So it's basically like this, or there. And then for 3 state, this vertex has nothing around it. Okay, I think I actually understand what he's saying here now. I've looked at this article several times and never understood what he was saying. Let me just see if I can highlight it a little bit better on the drawing screen, so you guys can kind of follow what we're going to try and do here. Okay, let's go ahead, and that was crap. Let's do that. There we go. Okay, cool. So let's switch to the drawing screen real quick. Okay, over here. So basically, can I make this bigger? I can. Cool. Bigger? No? Okay, maybe I can't. Whatever, it's fine. So basically, let's get a red thing. This vertex, can I zoom in? Okay, cool, I can zoom in. Right, this vertex is in a 0 state. Right here, that's what he's trying to highlight with this picture. And then this picture, he's trying to highlight this vertex is in a 1 state. And then this vertex is in a 2 state. And then this vertex is in a 3 state because it has no blocks around it. And I think it's basically like how many blocks are surrounding you. Yeah, okay. So he's basically trying to use symmetry to define like the only possible values for ambient occlusion, which turns out you only have these 4 values, right? So if you have a block to the side and the sides, like both sides are occluded by these blocks, then you basically get the 0 state, and this block kind of has no effect on that. Yeah, because it's still the same state. And then he's basically categorizing this where if you have like 2 blocks, but you don't have a block over here, right? It's kind of mirrored there. This is the 1 state. And then if you have 1 block and air around the rest of the areas, you have a 2 state, and then that is a 3 state. Okay, so let's try and use this information. We basically want to categorize each vertex now based on the blocks surrounding it. And actually, let's take a look at this again. So if we're looking at the top face, which is what this case is, the blocks we want to check are the top. If you go up, right, we want to look at the up. That's an up arrow. And then this is the left. This is the right. And then we want to look at the back, right? Up. So we would do up, left, plus right. So we basically have these 3 values, right? 1, 1, 1. We want to check, well, not directly above, but this up arrow, we want to check above and to the left, above and to the right, and above to the left, right, which would get us back there. And those are the only 3 blocks we would check for that vertex. So if we were to mirror this and like say we were checking for this vertex, we would check up and then we would check back and we would check left. For this one, we would check up and we would check left and we would check back. Okay, I think I've got this. Maybe. We will see. Let's see if this works. Fingers crossed, guys. Because I actually think I understand that for the first time. I've looked at this article so many times and never understood what he was talking about, but I think I get it now. Okay, so let's try and think about this analytically and a little bit abstractly, so we don't have to write like a million lines of code for this thing. We basically need those 3 blocks, which are up, left, right, back. So we need like up, left, up, right, left, right. Okay. And technically these won't be like actual up, left, right, or whatever, right? It's just kind of conceptualized that way for us. And then what we can do is, okay, and then this is gonna get kind of, okay, yeah, and then we don't even need this stuff. We don't need to switch on the sides, because what we can do is as long as those are like the appropriate blocks. So like if it was a different vertex, it would be like back, left, right, whatever, right? What we can do is we can say return if up left is not an error block. Actually, we might want to do dot is transparent. If it's not transparent and upright is not transparent, okay, we're in a state 0. This is a 0 state, right? Or I guess technically in our case, it's a 3 state because we're reversing it. So this would be a return 3. And since we don't really care, like if both of these are not transparent, it doesn't make a difference whether that one is transparent or not. So we can just ignore it. Cool. So that's a 3 state, right? It doesn't matter. Yeah, it doesn't matter. Cool. So then we can say else if up left dot is transparent. Okay. So if this is not transparent, let's see, what are we at? So that covers the 0 state. So now we're checking if this guy is not transparent. We could be in a 2 state or we could be in a 1 state. How do we know? Well, if this block is also not transparent, then we're in a 1 state. Otherwise, we're in a 2 state. So then we could just say if not up, left, right, dot is transparent, then we're in a 2 state. Whereas we're in a 1 state. This is going to be incredibly obtuse when I go to look at this code like a year down the road and I have no idea what I was doing here. This is horrible code. Let's say check this article for an idea of what is happening here. And then we'll say the states are reversed. We use 3 as the 0 state and 0 as the 3 state in that article. Okay, cool. That way I can at least sort of go back and figure out what I was doing here. Okay, anyway, so if up left is not transparent, then we can figure that stuff out. Then we can say else if up right dot is transparent. If it's not, then we can say if not up left right dot is transparent. Return we're in a 2 state, otherwise we're in a 1 state. And then finally we've got else if not up left right dot is transparent. This is last 2 state. 2 state or 1 state? Wait a second. This is the last 1 state, right? Yeah, because we're reversed. This is 2, this is 1, and ours. And then this will be 0. Okay, and then otherwise we're in a 0 state. Cool. Cool. I think that's basically it. I was thinking for a second, because like you see in this one, like these sides are dark and that side's light. I think that'll automatically result if you're doing this properly. Hopefully. We'll see. I don't know. Okay, but I think that's basically all we need. Now we need to figure out how to get these values. Up, left, up, right, up, left, right. Which will change based on which vertex we're looking at and which side we're looking at, right? So what we can do is we'll probably have to like... Yeah, this is going to be a bit tricky to get the appropriate blocks now. At least in a generic way. Like, I'm probably going to do a big switch statement and just do it all by hand, which is probably the easiest thing we can do. Okay. So this is getting the ambient occlusion levels for block I, V, and I think if I look, this get light vertices by side. I'm not sure if this is sort of doing the same thing that I'm about to do, which is like get the corner blocks, I guess if you can call it that, like those corner blocks for this vertex. Yeah, I think that's probably what's happening there. I think that's what's happening there. Wait a second, let's look at this again. Because if it is, then I can just reuse this. So this says if it's the right side, then V0, we basically add values to V0, 1, 2, 3. And what are V0, 1, 2, 3? They're just the vertices. Okay, so these are just the vertices of this face. Yeah, I think this is doing what I want. Okay, so what we can do is we can just use these V0B, 1B, 2B, 3B. Is it? Wait a second. I think this is doing what I want, but I can't be quite sure. Yeah, so I think this is getting like the top block, back block, left block, right block type thing. Oh no, this is getting an across is what I think this is doing, which is kind of opposite to what we want to do. But we can do something similar. So instead what we're going to do is we're going to do like something like get ambient occlusion vertices by vertex. We'll pass it the side. And we'll pass it what our vertex is. Oh, and that's what he's doing here anyways, just passing. Oh, okay, I kind of see what he's doing now, yeah. GLM IVEC3, AO V0. So ambient occlusion V0. This is horrible variable naming and everything, but it's fine. IV, right? Because these are all the same, right? This is just the vertex. And let's actually call this ambient occlusion top left. Do that. AO top right. Do that. AO top left right. Okay, so we initialize those all to the same thing, and then we pass in the side, and we're going to pass in top left, top right, top left, right. Okay. That should give us the offsets to get to the appropriate blocks, and then we can do something like we're doing here and basically just say const block ref AO top left block equals get block internal chunk AO top left dot x AO top left dot y AO top left dot z. Okay, and we can do something like that. What, you don't like this? AO top left. Oh, I didn't have that capitalized. Okay, cool. So we'll do that for top left, top right, and top left, right. Okay, which of course these are just sort of not the actual top left blocks and stuff, but it's kind of like an abstraction. Okay, so we just do that. We go down to here. We do that right here. And then we can say get ambient occlusion by light level, and we will give it the blocks, right? Top left block, top right block, and top left right block. Okay, and that should be good. And this returns, yeah, we don't need to do this because these are all the same size anyways. So yeah, they're 64 bits, so reference or copy does not matter here. Okay, so I think this is the last function we have to implement. Once we get this working, we're good. So let's do it above here. This is going to return nothing. It takes in a side and vertex references, reference, and reference. Okay, And then we're gonna do something similar to here. We go by side. Ooh, and we need to know like exactly which vertex this is, like which corner we're looking at. So let's actually say corner. We're gonna pass in two things. And then corner is gonna be like a 4-state thing. Yeah, and this is gonna be side. Okay. And then based on the side and the corner, we can get the appropriate offsets, which we'll look at in a second. SE Woods, do you find some off-screen time working on this project? This week, I had no off-screen time working on this project. That's just because I was busy this week with work and stuff, and I don't know, winter makes me kind of depressed, so I don't work nearly as much as I usually do in other months and stuff. Yesterday, I finally started finding motivation to work on the video. That should be coming out hopefully within the next week. So I've got a lot of work to do with that, but yeah. So I usually work a little bit less during the winter and stuff. So yeah, usually though, I do have time. I've also started playing Legend of Zelda Link's Awakening, which is like a remastered version of the original Legend of Zelda, which I've never played, and I actually really like this. So I think it's more fun than Breath of the Wild, which I kind of just abandoned because I wasn't having that much fun playing it. So okay, so we've got this. This is telling us which face we're on, and then we basically need to go from the face, figure out which corner. Which, like, that's just kind of annoying. I'm trying to think if, like, we can abstract that anyway. CGO clan, generating OpenGL bindings for Rift generated by GLAD, which itself is generating using Python is a pain, not gonna lie. I bet. I know Voxel Riffs will be appreciative though. If he's in here, I think he might be in here too. Let's just do a switch corner real quick. Case 0, you can say like top left. SE Woods, all good. I see there are good daylight outside now. Go get some later. Yeah. I will be hanging out with some friends later today, so hopefully I will get to get some good daylight, which will be nice. Okay, so case 0, case 1, which, let's see, we'll do that. Oh, you are here. Okay, cool. Okay, case 2, and then we'll have like case 3. I'm like debating whether this is even actually necessary or if we can just sort of take like a direction. Yeah, this isn't even necessary, is it? We can just take a direction. Never mind, let's get rid of this. We can just say like GLM IVEC3 direction. And this direction will basically be like, say we're in the top left corner, right? So that would be like, right, we have something like that. So say we are here, what we can do is we can pass a vector that's like, X is negative. Let's just draw this out, right? X is negative, Y is positive. Direction. And then I guess, let's say this is like all part of a Z-axis too. Can we do like a Z-axis, like a slash? Nope, slash isn't steep enough. I'm trying to see if there's any ASCII keys that has like an angle that I can use. This is fine. So yeah, like we do that, and then we have like that, right? So let's maybe do it like that. Okay, cool. So like this is the top left back of the cube. So we could say that's like -1, 2. Or actually, I guess X is depth. So that would be like that, and then 1 is positive Y, and then -1 in the Z direction, which would be left, right. And so what does this allow us to do? It allows us to say like, okay, what we want to do is we want to go this direction in the Y to get up to here, and then this direction for X, which will get us this block, that direction, for this block, and then this direction, this direction. Okay, yeah. So this works out good. Cool. Hopefully that made some sense. What we can do then is we can basically say, okay, so the AO top left equals direction dot X direction dot Y and 0. Okay. Or I guess we would say like plus equals. But yeah, it's the basic gist of this. Oh, and this is for the right face though, so... Can we determine... This is unnecessary if we have a direction. Okay, so let's change this one more time real quick. We're gonna say int direction and int corner. I mean inside and int corner, and then what we can do is we'll have like one last function, which is get direction from side and corner. Okay. And then we can just say glm ivec3 direction equals get direction side corner. Okay, and then we can get rid of all of this because now at this point it doesn't matter. Okay. And then we can say AO top right plus equals direction 0 direction dot Y direction dot Z. AO top left right equals plus equals just direction. Okay, cool. So that's basically how we'll get our offsets, and now getting the actual offsets. So top left back would be like -1, 1, -1. Yeah, so now we basically just need to do something for those. So like switch side and then switch corner. Which, do I have those stored somewhere? I'm wondering, because if I do, then I can simplify this a lot more. Okay, only add the faces that are not called by other blocks. Oh yeah, I think I do, right? Left, right, bottom, top, back, front. Where are verts? Yeah, I think this... we can use this to calculate exactly where we are. Okay, so we've got an XYZ. Okay, yeah. Sorry. SE Woods, are my brothers excited for the project? They are pretty excited too. They're waiting on me right now because I've got stuff to do. So trying to get this stuff a little bit better so that they can actually keep working and everything. But they've built some cool stuff, which is awesome to see. Okay, we can get the direction really easy just by doing direction minus XYZ. I think that's how this should work. So we can say glm ivec3 direction equals verts minus that. And I think that's all we need, right? Because if we look at this, that will be in 0.5. That will give us like 0.5 values though, which isn't good. So like we have verts, right? Which is the corners of the cube, XYZ. And then we basically add, oh wait, no, this is 0, 1, 0. Okay, yeah, so that's good. I think this is the bottom left back corner of the cube. So if we do that plus 0.5, that should give us like directional values, I think. So let's do this. We'll say that this, can we just like change that by doing this? Does that work? Yes, it does. Okay, cool. So we're gonna turn that into a float vector, add, subtract this. This will give us like negative or positive values, and those negative or positive values will sort of be the directional components. So let's direction signed, and then we can say direction equals and then this will be like sign of, what does this return? This returns gen glf type, whatever that is. Okay, so I think this is just gonna give us like positive or negative, like 1 or true. Or 1 for false, true or false for positive or negative. So if we just do that direction dot x, actually we could probably just do, if this works for that, we could just say sign of direction signed. Let's just make that auto, see what. Okay. I think that's all we need to do. I think that should work. I'm not quite sure though. Okay, and then if we just change this, we don't need this. We should be able to do that. And we should be good, I think. Let's just see if it works, I guess. We'll see what happens here. We're missing something. There we go. Okay, let's see what happens. SE Woods, are you working on Steam page or too early? Yeah, it's too early for that. I think I'm gonna be like creating a website for it and everything too. Because I don't know if I'm gonna even go with Steam or whatever to launch the game and stuff. I think it'd be cool to actually create a website and everything. Vox Riffs, it's gonna work first try. That would be awesome, but I don't have high hopes. Okay, we've got something going on. Okay. It looks like it's almost there. It looks like we're just messed up on that vertex and that vertex and that vertex, but everything else is working good. Sort of. Or actually, you know what it is. No, yeah, I think we're almost there. I think we're really close. I think the only thing is we need to like, okay, this doesn't look very good because we're not interpolating. Let's interpolate in the shaders real quick too and stuff. SE Woods, I've been following Ultra for a while. It's a new competitor for Steam. From what I've read, it seems legit and very game dev friendly and will only take 12 to 15% off the revenue compared to Steam's 30%. So time comes you might want to check it out. Should be possible to release on both platforms, I think. Huh. I might check that out. Just see what that's all about. Still think it's too early for me to think about like store pages and stuff in general, but when the time comes, I will definitely check out the different options and stuff and see what I'm feeling might be the best. Okay, let's do this. Instead of doing we're gonna make this a float, and this is gonna interpolate. And what we're gonna do is say this turns it into a float. We'll do that. And what we can actually do is we can divide by 3. right? Because then that will give us a normalized range from 0 to 1, and we can sort of scale based on that. So let's do that too. We've got a normalized range now. F ambient occlusion. It's gonna be a float. Okay. And we may. Okay, yeah. So we're kind of turning this into a float, anyways. Is F light level a float? Okay, it is. Cool. So yeah, so we can do this, and what we can do is we can actually scale our ambient occlusion. We'll say like float scaled ambient occlusion, and we'll multiply it by like we'll do like 5. So that should give us like a variance of 5 light levels. Do that. Okay, and it'll interpolate it too, which is good, because that means we should get like a smooth gradient from one side to the next. So let's see if that does what I'm thinking it'll do. Holy crap, guys. Holy crap. Look at that. It's not quite right, but look at that. It's very close. Do you see how we have the gradients coming out of there? I was not expecting this to work at all. Oh my gosh, guys, look at this. This looks so much better. I cannot believe this is actually working. Holy crap. We've done it. Okay, we've done it. Yeah, I am just as surprised as UKVBA music. I cannot believe that's kind of working. So I think we just have like some values flipped, possibly. It might be useful to actually switch it back to the non-interpolated part, because I think we have them like flipped on the sides or the axes or whatever. So if we flip them back the other way, then we should be able to sort of get it, because you can see it's like bright on the wrong side. So let's switch back real quickly. We'll do this. We'll comment that out for now. Let's actually, we'll copy all this stuff, paste it here, and then we'll say comment, because it's easier to look at it in the flat style and sort of tell. And then we'll say to do remove me. Okay, and this will take in just this. I was not expecting that to get as close as we did. Like, this is actually really close, and I'm really hopeful now. So let's go ahead, we'll change that. Let's also do this. We'll say to do remove me. This is gonna be a flat in int f ambient occlusion. Okay, and then we'll do a flat out up here, and we'll say a remove me. To do remove me. This is gonna be a out int f ambient occlusion. Okay, and then we basically need to just copy that, and then we'll say that comment, and we'll say to do remove me. Okay. Comment that. Okay, and then we'll just do that and that. Okay, cool. And I think that should be it. And also, that can just be float. Okay, and then once we get it working, we should be able to just remove this stuff, and it should just work. So let's go back into here. I got an error. Line 91, expecting a comma or a semicolon, which is actually gonna be like line 90. Okay, right here. Let's see, what did I do? Two main parentheses. There we go. Okay, let's go ahead. Stop this. Restart. Okay. Voxriff, you wasn't far off when you said it's going to work first try. That is really true. Ironically, that was meant to be a joke. No, I totally thought it wasn't going to work either. So I'm very surprised that it did work as closely as it did. Risk XY, how's it going? Good to see you. Okay, yeah, so I saw this and I just automatically assumed, oh no, this is not working at all. But actually, if we look at this, you can see it's kind of almost there, right? And now you can kind of see how the gradients were working. Basically, what we want is we want this corner to be over there. And I think this might be as simple as I have like our top left and top right backwards. It might be that simple. So if we go back to where, yeah, where we had this, I might just have these backwards. So let's swap them and see if that fixes it. And if it does, then I'll swap it in the function so that actually makes sense and everything. Okay, so if we do that. Oh, wait, no, that's wrong too. It did swap stuff, but that's wrong too. Actually, wait a second. Is it? I don't know. Oh yeah, that doesn't matter at all. I don't think so. Top right. Okay, let's do that. So we've got the direction, right? Okay, so this is the direction, which should give us ones or zeros, or -1, maybe. Let's see how that function works real quick, because I'm not even sure. GLM sine to IVEC3. Okay, let's see. Sine. Nope, let's GLM sine. Okay, here we go. Let's see if they give us more information. Okay, so it returns 1.0 if x is greater than 0, 0.0 if x equals 0, or -1 if x is less than 0. So this is doing what I expected to. Cool. So basically what this does is this gives us the direction like in a 1 or -1, depending on if we have a positive number or a negative number. And then what we're doing here is we're taking our center point and subtracting whichever vertex or corner we're currently on, which should give us like a vector that's like the actual offsets we need. So then when we go into here, I think what I'm doing here might just be wrong. So left, right, is this? Let's switch back to the drawing screen real quick. So what I'm assuming top left, okay, so yeah, this is on the x-axis, this is the z-axis. So maybe we should call this like, instead of left and right, let's make our naming a little bit better since it looks like this is actually working. So AO X direction, AO Z direction, right? Okay, so we'll call them that. X direction, and then that's adding in the X. This is adding in the Z. And then this is AOXZ direction. Okay. Which is all that stuff. Let's go back down to where we were and rename them up here too. So this is AOX direction. This is AOZ direction. And this is AOXZ direction. Okay. And we'll pass in X here, Z here, XZ here. Cool. So then what we can do is, yes, so then what we can do is we can rename these as well. So this is going to be AOX block, AOZ block, and this is going to be AOXZ block. Okay, so then this will take in the X direction. This will take in the Z. And this will take in X and Z. Okay, and then we can pass in X block, Z block, XZ block. Go here, rename these, X block, XZ block. Okay, cool. So now we can say if the X block is not transparent and the Z block is not transparent, we return 3, which is our max value. If the X block is not transparent and the Z block, oh, and the XZ block is not transparent. Okay, so if we, okay, let's think about this critically for a second. So this is if both of those corner blocks are not transparent, we return 3. This, and then if we hit this, this means that this block is transparent. So then if we hit this one, then it must be 2, it must be 1. Otherwise, if we hit Z block, then it must be okay, there's only one other case here. Okay, so if this is not transparent, this is not transparent. Okay, then we say, okay, if this is not transparent, then this must be transparent. Otherwise, this must be transparent. So there's only one other case here. So this would be, we don't have to do that, and that means this case is flawed, which might be our problem. Okay. So then we basically just need to check and see if XZ is transparent. We return 2, otherwise 1. Okay, otherwise we need to check that last block. If we didn't hit any of these cases, we can say if XZ return 1, otherwise 0. Okay. So this sounds right to me. Let's see what happens now. Let's see if we get the correct gradient directions and stuff. And I've got a bunch of sunlight in my face. All good. You know, you put your desk in front of the window because you want to have sun streaming in and everything, and then it's like right in your eyes all the time. But it's all good. Okay, so we're still not quite the right directions. I'm trying to think though if we are. I can't tell. So this is the darkest, which is true. This one should be... Yeah, this is right. Wait, no, is it? No, because this technically has... So this should be a light level of 2, is what we should get here. Like, 2 should be there. Let's actually color these, right? Can we do that? Let's do 3 is red, something like that, right? Let's see. So can we change light color? Where are we getting light color from? Light color. Was that times F light color? Okay, cool. So we can just change this to like, we'll say vec4 temp color equals, and then we can say what? F ambient occlusion equals 0. This is temporary code, so I don't care about doing switches and all that stuff in shaders right now. We'll do like vec4 1001. Otherwise, if ambient occlusion equals 1, do 0101. Otherwise, ambient occlusion equals 2, 00101, I mean. Otherwise, we'll do vec4 1101. Okay. And then we'll just change this to temp color. Okay, so that should give us like colored vertices, which will be nice at least. I'm also interested to see where they split on this, because I'm not sure how the shaders will split that stuff up. Let's see, what do we get? Too much data in type constructor. Too much data type constructor. 4 values. 4 values? 4. Oh, okay, this should be a vec3. And let's just get rid of that guy. And we should be good. Okay, let's try that again. SE Woods, is the code becoming a hot mess as the project expands, or is it still organized and fairly easy to manage? There are certain portions of it that are kind of like a hot mess, and I think the key to fixing that is just trying to modularize the code, right? Where you basically have specific modules that only focus on themselves. Like the way when code complexity increases, it's because you have like some thing that affects another thing, right? And once they all start affecting each other, it's like it gets too complex to hold in your head. So the way to reduce that is to minimize, this is cool, is to minimize the amount of things that you can represent and stuff. This is really cool. Okay, so it's not exactly changing vertex colors though, which is interesting, right? Because this is all yellow. I would expect to get like different colors for each part. I don't know if maybe you can't do that with flat. So let's change this again from flat to not flat to see if that at least helps. So let's do that. Let's do that. That. Okay, and then let's also do that. Okay. Did I do it right down here too? I just want to make sure. Yep. Okay. Let's see if we get something a little bit better with this. Go back into here. Shaders. Okay, now it's all just yellow. That's not good. Why is it all yellow? It should be in... Oh, it's because that makes sense, actually. Because if we're interpolating, we don't get any specific values. Okay, so we'll say if it's greater than... instead of equals 0, we'll say like if it's less than 0.5. Otherwise, if it's less than 1.5. Less than 2.5. Is that right? No, I want to do less than 1. Less than 2. Less than 3? Is that right too? We should have 0, 1, 2, 3 is the max. I think that's actually better, right? Wait, 0.5. Yeah, we'll see how this turns out. I think this is still not quite good, but it should be better. Load shaders. Okay, cool. At least we're getting like kind of different colors. I still don't have that quite right. Cool patterns though, right? Let's screenshot that. SE Woods, if you want to change one thing but then have to go to 6 different classes to get to work, I don't like that. So yeah, that's exactly the problem with like increased complexity and stuff. Once you start increasing that complexity, you get to things like that. And once you're doing that, you know that you need to reduce the scope of certain classes and stuff. Yeah, it does look cool. It's still not very helpful to me though, because I still can't tell which parts are which. Let's see if we can fix that a little bit. So if we're less than 0.5, this is a 0 ambient occlusion, right? So we color it red. For less than 1.5, so this is between 0.5 and 1.5, we should be green, which is a level of 1. This will be between 1 and 2, which is a level, so that would be blue. And then yellow would be if we're greater than 2.5. Okay. And I don't see any yellow or blue, which is kind of concerning. Actually, maybe it's not. Maybe it's because we would see it on other sides. This is interesting. So this kind of gives me hope. These are all red, which would kind of make sense, right? Because all these vertices have the same state, right? There's no blocks on top of them. What is red again? Red should be the 1 state. Right? Red is 1? No, red is the 0 state. Okay, and what is the 0 state again? Let's look at our code. The 0 state is reversed from his states. Let's go back here. So this is 0 state. Okay, cool. So that's good. That means like we have no blocks on top, which makes sense, right? These all have no blocks on top. What about green? What is green? Whoops. Green is the 1 state. What is the 1 state? That's if you have 1 block in one of your corners. Does that make sense? Okay, this vertex has one block here. That makes sense. This vertex has one block here. That makes sense. This does not make sense, right? These vertices should also... This has one block here. This has one block here. So they should have the same state as well. So that's already a problem. For some reason, and it looks like it's only on like negative directions, right? Because we have it, it's right here, it's right here, it's wrong here, and it's wrong here. Which directions are those? So if we go forwards, we're moving in the negative X direction. So negative X is okay. And then if we go this way, we're going positive Z. Is the positive Z okay? Yeah, and positive Z is okay. So positive Z and negative X are okay, but the other ways are not okay. That's weird. I guess the best way to just... I think what's happening here is this direction value is wrong. Right here. I think that's what's happening. This direction value is not what I'm expecting or something. Oh, and you know why it's not what I'm expecting? That should be that. Okay, let's see what happens now. Voxros, you're only looking at positive directions for blocks, aren't you? Yeah, and I think that might have been why we were kind of like getting double negative or something. Eddie Dev, you must go now. It was good to see you. I'm glad you were able to make it to the stream. And hopefully we're on the verge of getting it solved. Okay. This is looking good. Kind of. Okay, I think I see what the problem is, right? Okay, so if we're on the bottom, we want to subtract... Okay, I think it's just our Y values, right? If we're on one of these bottom corners, then we want the Y to go down. But if we're on these top corners, we want to go up. And if we're subtracting, this would be like 0.5 and 1. If we do 0.5 minus 1, that gets us negative 1. 0.5 minus, this would be like 0, which would get us positive 1. Which, is that right? Wait a second. I'm trying to think of this now. Dark physicist, nice job, thanks. I'm trying to think, wait a second, because now I'm getting confused. So this is for looking at this vertex. This is assuming we're on the top of a block. What if we're on the bottom of a block? Then we want to look down. Like, what if we're this vertex? Well, no, yeah, if we're this vertex, we're just the top of this block. I think my problem is, like, we only ever want to look as if we're looking from the top of a block. And right now what I'm doing is I'm also computing the values for like the bottom of blocks, but that doesn't really make sense. I think. Let's take a look at this again. Because if you notice, like, this is correct. This is correct. At least I think it is. What is red again? Let's double check this. So if we look at red, red is this one, which is the 0th state. And what is the 0th state? 0 state is this one. Yeah. No, so that's wrong. We should be getting a 1 state there. So that should be green. And all of these are getting green. Yeah, and I think this goes back into the problem that I was just thinking of. So when we're looking at this block specifically, we go down and we go here. What is this vertex? I guess this is what I'm struggling with. What is this vertex? It's connected to this block, it's connected to this block, and this block. What are we looking at here? Is this vertex a part of this block, or is this vertex a part of... Yeah, okay, I think this is our problem. So I think basically like my problem is I'm assuming that you can go down, but I don't think you can actually go down. But you can, wait a second, because it does make sense, right? What if we have a case like this and we have like other blocks here? Or I guess in this case, we would do a block here, here, and here, right? Okay, so then we got there. So now in this case, this vertex wants to look up to get the appropriate ambient occlusions. Whoops. This music is also really nice too. I don't know if you guys can hear it very well, but so I guess this is kind of the struggle. What is red again? Let's see if that's at least giving us the right values, because I think that should be. Red is 0 state. What is 0 state? No, that's definitely not the right. We should be getting a 3 state here. Yeah, because like basically what my problem is, if we look at this vertex, technically that's the top of this block, but it's also technically the bottom of these blocks. So how do we treat it? Do we treat it as the top or do we treat it as the bottom? Well, it depends on what context we're looking at. If we're looking here, we treat it as the top. But then if we treat that as the top, what we're really looking at is we're looking at this guy right here, right? When we're looking down here, we're looking at the top of this vertex is how we should be treating it. And so it kind of has like two different contexts. So I guess the face kind of does matter, which face we're looking at, right? Okay, I think we might be able to fix this. So basically, if we're looking at the top face, we're looking up. I may be overcomplicating this. I don't know. I think we're getting pretty close though. Let's just change the shaders back real quickly. I'm gonna comment this out, but leave it because I'm gonna do some more testing. If we uncomment that again, let's just take a look at what we've got when I change that one thing. We hear the music, but it's constantly being interrupted by some guy talking. Yeah, that's true. Let's see, what did I mess up? Light color. Where do we have light color? Oh, I gotta leave that one. Wait a second. Oh, and I want to change this back. Okay, wait, so let's copy this. And we'll paste it here. This will be object color. And then we can comment that out. Okay. Let's see what we get this time. Nope, we're still broken. Light intensity. I'm missing light intensity. Let's see. Did I remove the wrong stuff or something? I'm so confused. Wait a second. Sky level, combined light level, light color. We need this again. Okay, yeah. I think we should be good now. Hopefully. Okay, and nope, we are not good still. Okay, undefined color, or base light color. What is that? Base light color, 0.1. Okay. I must have just gotten rid of all of this stuff on accident. Wait a second. Okay, base light color, light intensity. Okay, yeah, those are the 3 things I was missing, I hope. No, dang it. What do I keep missing? Too much data in type constructor. Object color is a vec4. I'm having trouble remembering how this worked before, but I think that should be fine. Okay, there we go, finally. Whoa, okay, what did we do here? I clearly did not do that right, because this does not look right at all. Let's take a look at some old code so that I can fix that. So let's go back up to here. This is the opaque shader. Okay, and then we need to fix this stuff. Okay, we'll do that. Go into here. All the colors look burnt. Yeah, I've done exactly 0 work in the shaders for now. Hey, that's fine. If you don't need to do the work, then don't do the work. That's the best way to do it. Okay, if we do scaled ambient occlusion, I think we need that again though, so let's do that right before we do sky level. And then that's minus scaled ambient occlusion, so we'll do that. Minus that. And then we'll get rid of all this stuff. Okay, that should bring us back to the normal stuff, I think. Reload shaders. There we go, okay, that's much better. Man, what a difference. Okay. So what I did clearly is still not working. I'm wondering if it's kind of reversed though. Let's see. Okay, yeah, you can see that it's like now working in actually this corner. I think if we were looking upside down, yeah, it's kind of working from like the top down. I'm gonna have to come up with a better system to figure out the directions for all these values, but we're close. We're pretty close. So I think I'm probably gonna end the stream right about here, just because I have other stuff that I got to do today. Thank you everybody for coming though, and we are pretty close to having this working properly. I just got to fix that directional component. I think we should be good after that. As you was, did I mention I was playing Zelda? I think they work on Breath of the Wild too, if I'm not mistaken. I was, but I'm playing the remastered version of the original Legend of Zelda. So it's like called Link's Awakening. And I actually like that a lot more than Breath of the Wild, because I like a very linear story rather than an open-ended story. Yeah. This is pretty cool though. I'm glad we made some progress. I just need to figure out how that directional component works, and then I think we should be good. But we've got like sort of the basic structure in place to make sure that this all works. So yeah. Anyways, thank you everybody for coming. It was good to see you all, and hopefully I'll see you guys next week at around the same time. All right. Thanks guys.